Hi class, in this geometry lesson we're going to be actually doing a lot of algebra. We're going to be solving equations using algebra, but we're going to prove each and every algebraic step that we use with some properties that we're going to be talking about called properties of equality. So this is 2-6 algebraic proofs. So these tools that we're going to be talking about right now to prove something, you have to make your case. Each step along the way helps validify your statement even more. So we're proving an equation true. They're called properties of equality. The first one is called the reflexive property. So it says for every number A equals A. We're not going to use this very much today, but we'll use it a little bit later when we do more geometric proofs. Let's say we have this triangle, and let's say we have this triangle. And if I say that the triangles are congruent, they are the exact same size. So maybe this is the same size as this one. This one is the same size as this one. And if I call this A and I call this B, doesn't segment AB exist in the red triangle and in the green triangle? Right? They share side AB. So AB, that segment, is congruent to itself. Of course it is. It's the same size in the green triangle as it is the red triangle. So that's called the reflexive property. We're not going to use it very much today, if at all today, but we will be using it in the future. The symmetric property. When we solve an equation, sometimes we get something like x equals 7, and we're kind of used to seeing the variable on the left side, but it's the same thing as 7 equals x, right? It doesn't matter if x is on the left side or x on the right side. The symmetric property states that. If 5.3 equals x, then of course the other way around, x equals 5.3 is the exact same thing. It is equal, property of equality, using the symmetric property. The transitive property for all numbers a, b, and c, if a equals b and b equals c, then a equals c. So here's just kind of a funny cartoon, I guess. If every house has a clock, and in every clock lives a mouse, then of course the mouse is going to live in the house. In every house lives a mouse. If we use this into math terms, let's say I get an answer like 7 over 2. 7 halves. Isn't that the same thing as 3 1/2? And isn't that the same thing as 3.5? Those are 3 ways to write the exact same number. So in a way you could say then that 7 halves is the same thing as 3.5. Then A equals C. 7 halves equals 3.5. So that's a similar instance. I could say like A equals 12, for example, and 12 equals B, then couldn't you say that A and B equal each other? If one equals 12 and the other equals 12, then of course they have to equal each other. So A equals B. That's the transitive property. These two properties I'm sure you'd have no problem with. The addition property is when you do something to the left side of the equation, you have to do the same thing to the right side of the equation, so that it balances again. So x equals 9. What did you do? You added to both sides. So that's the addition property, and the subtraction property is a very similar thing. If we had x plus 7 equals 2, the subtraction property of equality would be subtracting from both sides of the equation. So we'll be doing that several times today. Along with that is the multiplication and division property. If I first subtract 7 from both sides and I get 3x equals 6, that's using the subtraction property. Now I would divide by 3, so I would be using the division property. Or if I had 1/3 x equals 5, for example, now I would have to multiply both sides by 3, so I would be using the multiplication property. So that's pretty self-explanatory, I think. Substitution property, it's actually quite surprising how often we use the substitution property when we solve equations. The reason why is because whenever we clean up an equation, whenever we combine like terms, whenever we do that step, we're using substitution. This 4 divided by 2 right here, we're substituting a number that is equal to 4 halves. We're substituting in a 2. So whenever we combine like terms, or again, I call it clean things up. 4 halves is unclean, but 4 halves is the same thing as 2. We just clean things up a little bit. That is called the substitution property. We're substituting a 2 into the 4 halves. And so here's what this part says here for all numbers a and b. If a equals b, then a can be replaced by b at any time. So if a equals b, and we say the equation is 7a minus 22, well, if a equals b, I can substitute b into a anytime I want to. So 7b minus 22, it's the exact same equation, except instead of letter a, it's letter b. That's called the substitution property. You're gonna find that we're gonna use this a lot today. The distributive property, I'm sure you've heard before, is where when you have three, or a number times a binomial or a trinomial, any polynomial, you take the number outside, the coefficient, and multiply it by every term in the polynomial. So 3 times x is 3x, and 3 times the negative 2, of course, is negative 6. We're using the distributive property when we do that, as this one states. If you take a times b plus c, it's the same thing as ab plus a times c. All right, now that we know all of our properties, you guys solve this equation just like you've done for the last 5-6 years when you've had equations and stuff like that. Don't worry about writing any properties, but make sure that you show all your work, okay? And I want you to start by using the distributive property, okay? So pause the video, solve that equation on your own. All right, we are going to have 3 problems here in this video lesson where we are going to, at length, show our work, and we're going to have a reason for every algebraic step that we do. Okay? So we're going to have our statements over here. So this is where we're going to like show our work. This is what you're used to doing. This is what you've done the last 5 years in algebra classes. And then this right here is what we're doing today. It's what we're learning. It's what you haven't done before. It's the new thing. Okay? So we're going to give all of our reasons, those properties of equalities that we've been talking about here the last 5 minutes. So the first thing we're going to do, what you're always going to start off with, is you're going to start off with the given information. We're going to use this, and we want to prove that x equals 2, right? So that's the very first thing we're going to write down is the given information. So 3 times the quantity, x minus 5/3 closed quantity equals 1. And the reason is that is our given statement. So in my class, you're always going to start off with that, okay? All right, step number 2. Now there's several ways to solve an equation, so you could solve this multiple ways, but I told you to solve first by distributing, okay? So here's what I want you to write, class, and I know it's kind of monotonous a little bit. It's a lot of work, but I want you to show your work in this way. We're going to use the distributive property, which means we're going to take 3 times x plus we're going to take 3 times a negative 5/3. Please write that down in your notes, and that equals 1. Okay, what property did we use here? We used the distributive. All right, now we're going to clean things up a little bit. We're going to substitute, statement number 3 here, 3 times x is 3x. It's like I'm substituting 3x into 3 times x. And I'm going to say it's minus, because this right here, 3 times a negative 5/3 is a negative 15/3, which is a negative 5. Or these 3's will cancel out, and you just get a negative 5. So I'm substituting in a negative 5 in for this number, because that's what that number equals. It equals a negative 5. And that equals 1. So I'm substituting 3x into 3 times x. I'm substituting a negative 5 into 3 times negative 5/3. So I'm using the substitution property. Again, you're going to get used to writing substitution a lot today. All right, the next step that you're going to do is you are going to add 5 to both sides. So here's how I want you to show your work. It's 3x minus 5 equals 1, and then you're going to add 5 to both sides. Just like this. So step number 4, what property did you use? You used the addition property. All right, now we have to clean things up. When we clean things up, we call that the substitution property. So step number 5, we have 3x equals a negative 5 plus 5 is 0, so we kind of substitute in a 0 there. And then 1 plus 5, we're substituting in a 6, because 6 is the same thing as 1 plus 5. So we used the substitution property again. Okay, our next step, usually we would say our last step, but this one is not our last step. It's our second to last step. Here is step number 6. We have to get x by itself, which means we have to divide both sides by 3. So we take our 3x equals 6, and we show our work by dividing by 3. Dividing by 3. And so our reason, when we divide by 3, of course, what property do we use? We use our division property. Now we're on our last step. Step number 7 is 3 divided by 3 is 1x, so we're kind of substituting in a 1 in for 3 divided by 3. And that equals 6 divided by 3. We're substituting in a 2 for that, because 6/3 is the same thing as 2. So number 7, we use the substitution property again. And as you can see, I have successfully proved all these 7 steps proves that x equals 2. Okay? So it's a lot of work. It's really showing your work in very great detail, but it's describing every step along the way. Here we go. Let's try this question. So again, the first thing that we're going to do is we're going to write down the given information as step 1. In my class, that's what you're always going to do first. So 7 times the quantity, 2x plus 1, that equals 63. All right. So that is our given information. Now, on our last question, I had you distribute first, which we could do again on this one, but just so that you can get a little bit of a different look, let's do something else here first on this one. If you wanted to, you could divide both sides by 7 right away, and that would be a property of equality that we could also use to solve. So for step number 2, if you do decide to distribute on a test, of course, that's great. I wouldn't dock you any credit. I wouldn't dock you off any points for that. But you could also do it this way. So what I'm going to write down is I'm going to write down 7 times the quantity, 2x plus 1. That equals 63. But I'm also going to write down both sides divided by 7. And that reason, what I did just now, is I divided. So I used the division property. Now I'm going to clean things up, right, everybody? When I clean things up, I use substitution. So step number 3, 7 divided by 7 is 1, so I just get 1 times 2x plus 1, which is 2x plus 1. I'm substituting in a 9 on the right side, because 63 divided by 7 is 9. So 3 is the substitution property. Okay, so now we have our next step, where we are going to subtract 1 from both sides. So step number 4, 2x plus 1 equals 9. Let's subtract 1 from the left and subtract 1 from the right. Number 4 is the subtraction property. Step number 5, we're going to clean things up here. So 2x equals 8. When we clean things up, step number 5 is substitution. Just about done here. We're going to divide both sides by 2 at this point. So step number 6, 2x equals 8. Divide by 2, divide by 2. So step number 6 is division again. And we're going to end with substituting, because when we get our final answer, 2 divided by 2 is x by itself, so we're substituting x in for 2 divided by 2. And 8 divided by 2, we're substituting in a 4 for that value. So x equals 4, there is substitution. And your last statement here should always match, of course, what you're trying to prove. We proved x equals 4. Voila! We got that right down there. All right, let's do one more together. Now this kind of is merging some geometry and algebra. So we have a picture. We're given that the measure of angle ABC and the measure of angle CBD equals 90 degrees. And then we're given the value of the two angles in an expression, 3x minus 5 and x plus 1 divided by 2. So we want to prove then that x equals 27. You learned on a previous video lesson that one of the first things that you do is you kind of mark up your picture. So let's do that. I have a little diagram at the right here, and it says that angle ABC is 3x minus 5. So I'll kind of put it in green here. ABC is 3x minus 5. And then it says that the measure of angle DCB right here is x plus 1 divided by 2. And we're also given that CBD equals 90. So CBD, this angle right here, is 90 degrees. And I think what we're going to do here, everybody, is I'm going to talk this one through with you as you get to class tomorrow. It'll be the very first thing that we do, so we could kind of all do that all together one time before you start with your homework for tomorrow.